When we convert from one concentration to another, such as to convert from molality to mole fraction, or convert from mole fraction to mass percent, or convert from molarity to molality, we can assume that we have any amount of the solvent. It does not matter how much solvent we assume in the solution. We will get the same concentration after the conversion. When I'm talking about amount, I mean kilogram, gram, mole, etc. We can also assume that we have any amount of the solute. We will get the same concentration after the conversion, no matter how much solute we assume in the solution. We can also assume that we have any amount of the solution. We will get the same concentration after the conversion, no matter how much solution we assume we have. But I want to warn you, only make assumption of 1. We can assume any amount of the solvent. We can also assume any amount of the solute. We can make assumptions of any amount of the solution. But I will not make assumption of more than 1. For example, I will not make assumption of any amount of solvent and any amount of solute at the same time. I will not make assumption of any amount of solvent and any amount of solution at the same time. Similarly, if you make assumption of any amount of solute and any amount of solution at the same time, it will be a bad idea. This is very important when you perform conversions between different concentrations. So, I strongly recommend you to memorize it. Let me use this example to demonstrate what I told you is true. We have a solution which is 1.00 mole per kilogram. This is molality. I want you to convert to mole fraction of the solute. Glucose is the solute and water is the solvent. So we want to calculate the mole fraction of the glucose. First, we will assume we have 0.100 kilogram of water in the solution. Then let's say what kind of mole fraction of glucose we will get. This is the definition of molality. Molality is defined as mole of solute over kilogram of solvent. We know the kilogram of solvent and we know the molality. We will calculate the mole of solute. The molality is 1.00 mole per kilogram. The answer is we have 0.100 moles of glucose. To calculate the mole fraction of the glucose, let's look at the definition of the mole fraction. The 3 lines represents definition. The mole fraction of glucose is defined as the moles of glucose divided by the moles of the solution, which is the sum of the moles of glucose and the moles of water. We already know the moles of glucose. To calculate the mole fraction of glucose, we need to find the moles of water. We already know the mass of water. We can use the molar mass of water to convert to moles of water. The moles of water in the solution is 55.5 moles. Let's plug in the values and we calculate the mole fraction of glucose. Sorry, my number is wrong. It's 5.55 moles of water. The answer is 0.0177. Mole fraction does not have a unit. Let's start to assume we have 1.00 kilogram of water. Let's say if we will get the same mole fraction of glucose. We will do the same calculation to find the moles of glucose and the moles of water. Then we plug in the values of the moles of water and the moles of glucose into the definition of the mole fraction of glucose. We do get the same mole fraction of glucose, so it does not matter how much solvent we have, we will get the same concentration. In this case, it's the mole fraction of the solute. Then let's look at the other two examples. Let's say if it matters, if we assume different amount of the solute. From the definition of molality, we know the molality and we know moles of the solute. We need to look for kilogram of the solvent. And this equation is from this equation. Let's plug in the numbers. If we punch these three numbers into a calculator, we will get 0.0177. We do get the same answer. Let's look at the last assumption. We assume we have 10.00 moles of glucose. The solvent is water, so we put down kilogram of water. Let's convert the mass of water to moles of water. Let's calculate the mole fraction of the glucose. If we punch these three numbers into a calculator, we will get 0.0177. From what we did, we can see that it doesn't matter how much solvent we assume. It also does not matter how much solute we assume in the solution. When we convert one concentration to another concentration, we will get the same answer.